Good morning. Today we are going to start with 11.3, vectors in the plane. And this is the first time that we cover vectors in math analysis. You guys usually see vectors when you guys are taking physics. So if you're taking physics, you guys have seen some of these components of the lesson. Go and take your time to copy the essential question. How do you represent and perform operations with vector quantities? You should have it cut out, or you can just go and copy it and just frame it. And example number 1. Go and pause it and we'll start once you're ready. Excellent. So quantities such as force and velocity involve both magnitude and direction. So we're going to have two components, magnitude and directions. It cannot be characterized by a single real number. We represent such quantities as a directed line segment, PQ. So in this case we have a P and a Q, which has an initial point, P, and a terminal point, Q. Notice that this is a ray, which starts with P and continues to Q. Now, there are two ways to be able to characterize a vector. Vectors can be thought of having a magnitude and a direction. So if I draw this, I'm going to place it in an overhead, and I draw it. And this is P, that's Q. These vectors can be moved around as long as they are pointing towards the same direction and they have the same length. So therefore, this vector is exactly the same. And we are able to move around vectors. Now, once it's landed, once it's written on AB, then that's going to be kind of directed and placed on an X and Y axis, and your starting point will be 0, 0. But let's go to the first example. Let U be represented by a directed line segment from P to Q, where P is at 1, 2, Q is at 4, 4. Find the component form of the vector PQ. So this is the component form. And in this case, it will be U. Notice that's in bold, so you want to make sure that you make it bold when you're writing it down. So let's go and just make it X and Y axis so we can actually see. Let's make it 5 by 5. So your starting point is 1, 2. Your endpoint is 4, 4. So in this case, we have the following vector. So what we want to do, we are going to take this vector, which is from P to Q, and what we're going to do, so this is P and that is Q. What we're going to do, we are going to bring it down. So your starting point, we want it to be 0, 0. So we are going to move it towards this direction. So notice that now your terminal point is at 3 and 2. So we are going to move it that way. So we're now going to do it using a graph. So what we did, we applied P and Q. And what we're going to do, we are going to ground it to the origin. And now we're going to be writing down into this notation, which is a component form of vector. So, and to do so, we can do it algebraically by just doing the following. So therefore, your component PQ will be equals. We're going to take the difference between your first point and then the difference between your x values and then your y values. So therefore, it'll be we usually do the second one minus the first one. So notice that's q minus p. So it'll be 4 minus 1. And we're going to do the same thing, q minus p. So it'll be 4 minus 2. And now we can simplify. So pq is 3 and 2. And we're going to represent it by the vector u. Notice I'm making it a little thicker, a little in bold. So that'll be 3 and 2. So it's very easy to calculate. Now the important part is that you actually see what's happening. We are taking a vector that's somewhere where your starting point P and Q. That's this one here. And we are going to ground it, where when you written in this location, in this notation, we know that your starting point is at 0, 0, and this will be your endpoint at 3, 2. Go ahead and take the time to paste your next cutout and make an X and Y axis on the left hand side. And then we'll start once you're ready. Go ahead and pause it, and then we'll start once you are ready. Excellent. So a vector with initial point at the origin in a rectangular coordinate system is called a position vector. A position vector u, just like we covered on example number 1, with its endpoint at the point A, B, is now written in the following form. And that's what we did on example number 1. So therefore, let's go and say we have a point somewhere. Let's go and use the previous one that we had here. And we're just going to call it, instead of x and y, it's going to be a, b. This is still your x, this is still your y axis. And now we are going to make our vector, and which is called a position vector because we start at the origin, and the component form is AB. So that's also called a component form, called a position vector if it starts at 0, 0, and we use this notation. Now the magnitude length of the vector, so the magnitude is going to be the length of the vector. So how will we calculate the length of the vector? So I'm going to make a right triangle where this is your x value, so that'll be your A, and this is your y value, which is your B. And we're going to find our magnitude, and we are going to use the following notation. We used to have C before. So let me write down C as we go through the work. So I can use Pythagorean theorem, and that will be C squared is equal to A squared plus B squared. I'm going to take the square root on both sides, and I end up with C equals plus or minus, but because we're talking about length, we're talking about distance, it's only going to be positive. A squared plus B squared. But now we are not going to use C. We are going to use the magnitude of U. Now sometimes they'll place 2 bars, sometimes they'll place 1 bar. In our textbook, they'll use 1 bar. So this is the magnitude. Now notice that if U is equal to 1, if the distance or the length, the magnitude is equal to 1, then that's called a unit vector. And if the magnitude or the distance, the length is 0, then it's called a 0 vector. Now the direction angle satisfies the following. So this will be your direction vector. That'll be your direction of the vector. Remember, vector will have two things. We'll have a length and a direction. So therefore, if I'm using B and A, I'm going to use tangent. So it'll be the opposite over adjacent. So therefore, the tangent of theta is equal to B over A. So very similar concepts that we covered before, but now we are going to translate them into a vector. And that's the direction of the angle. Two vectors are equal if they have the same magnitude and the same direction. So therefore, if we have two vectors, one and the other, they have exactly the same direction and the same magnitude, the same length, and we can move them around. Those two vectors are the same as long as they are the same direction, and they are, and the magnitude stays the same. So vectors can be moved around. That's something that you want to make sure that you understand. As long as we are able to keep it with the same direction, the length is the same, those two vectors are equal to each other. So they must be to have two things. For two vectors to be equal, they must have the same magnitude in the same direction. So let's go through example number 2. Go ahead and take the time to copy it down. Then go and pause it, and we'll start once you're ready. So find the component forms, find the magnitude, and find the direction of the following vector that has an initial point of 4, 2 and a terminal point of 3, 1. Now, one of the things that you want to make sure that you do is that you make an x and y axis and plot it. Otherwise, you might end up with the incorrect direction. So I'm going to make it 5 by 5. And I know some of you guys will kind of refuse to graph it, and that's when you guys will be missing very easy questions on the test. Same thing as before. So 4, 2, 2, 4, and up 2. That is your starting point, and your terminal point is 3, 1. 3, negative 1. So notice that now our vector is starting from here and is going there. So whenever you think about doing our component form, something that you want to think about is that what we actually are doing, we are actually taking our vector. Let's try once again. And so what I'm actually going to be doing, I'm going to take my vector. I can do this. There you go. And I'm actually going to take it and I'm going to ground it over here. So that'll be my component vector. So now it will be over here. Or before, your starting point was at 4, 2, and now it's at 0, 0. Before it used to be 3, negative 1, your terminal point. Now it's at negative 1 and negative 3. And now we can write down as negative 1 and negative 3. And that's our vector v. So let's write down v is equal to, we are going to subtract your x's and subtract your y's. Now somehow this question will be on your test, and somehow this is a question that gets missed quite a bit. I think people kind of lose the connection of what's happening. And we're just going to take 3 minus 4 and negative 1 minus 2. So therefore our component vector will be negative 1 and negative 3. Just like we have here. So we found our component form. Now we need to be able to find our magnitude. Remember, to find the magnitude, you basically are finding the distance from your starting point to your terminal point. But we're going to use this instead. We're going to use a component form. Now, some people just use the distance formula to find the distance between here and here. And I'll do it in a second. But let me just go and find my magnitude. And I should label things down. Component form. This is my magnitude. To find the magnitude, you're going to take the difference, so the square root over your a square plus negative 3 square. So now your magnitude is equal to the square root of 1 plus 9. So your magnitude will be equal to the square root of 10. Now remember that you can actually just, if you want to take your magnitude from the original information I provided for you, you can just take in the distance, which is the difference between the x's, 3 minus 4 square, plus the difference of the y's square, negative 1 minus 2 square. So your magnitude will be the square root of negative 1 square plus negative 3 square, which is 1 plus 9. So your magnitude is still square root of 10. But since we have it on this form, on component form, we can just take the magnitude. And now the last thing I need to be able to find is my direction. To find your direction, we are going to use tangent of theta is y over x, but in this case will be b over a. So be b over a. So your tangent of theta is equal to negative 3 over 1. Your tangent of theta is equal to positive 3. So therefore I'm going to use my calculator, and tangent of theta equal to 3. 3 is one of the values that we know, that we have memorized. So remember that you want to make sure that you have it on degrees. So therefore I'll take my inverse tangent of 3, and that gives me 71.57. Now one of the things that you have to remember is that tangent, whenever you guys are working with a tangent, if I just make a quick x and y axis, tangent is going to give you angles on your calculator for the inverse. It's going to give you either on quadrant number 1 or quadrant number 4. And your calculator is going to give you from negative 90 degrees all the way up to 90 degrees. In this case, this is the angle that we're looking for, which is, or this is the angle that we're looking for. It's over here. And your calculators give you 71.57. So your calculators give you this angle here, which is 71.57. So what do I need to do in order to be able to get to the corresponding angle that I'm looking for? I need to add 180 degrees. So therefore I'm going to take that plus 180 degrees. And that gives me 251 degrees, and that's what I'm actually looking for. So therefore my direction will be equal to 251.57 degrees. So that is essential. That's why it's essential for you to be able to do a quick sketch. So that way we know that the angle that you're looking for is the correct one, and square root of 2 or square root of 10 looks correct. And we can leave it as a decimal if they ask you on the homework, or in this case as an exact value, which is the square root of 10 for the magnitude. Example number 3. Go ahead and copy it down, and then we'll start once you're ready. Go ahead and pause it. So in this case, we need to be able to find two things, the magnitude and the direction. And we have 3, negative 2. I'm going to do a very quick sketch on the left-hand side, so that way I can see what I'm actually looking for. 3, negative 2 is over here. 3, negative 2 is over here. So I need to be able to find two things. I need to be able to find the magnitude, which is the length. And to find the length, I'm going to take the square root of a, which is 3 square, plus b, which is negative 2 square. So the magnitude is 9 plus 4. So the magnitude will be square root of 13. Now to be able to find the direction, so this is the magnitude, and your direction will be found by the tangent of theta will be y over x. So in this case will be b over a, which is negative 2 over 3. And can I simplify? So I'm just going to use my calculator. Find my inverse tangent. Make sure that you have it on degrees, since we are using degrees. And we have my inverse tangent. I'm going to use my fraction bar, which is negative 2 divided by 3. So it'll be negative 33. So what it gives me, tells me that my angle equals to negative 33.69 degrees. Now we know that that is not, I want the positive version. So that angle is correct because that corresponds to negative 33 degrees over here. But I'm actually looking for the positive version of it. So what do I need to do? I need to be able to add 360 degrees, correct. So the actual angle that I'm looking for will be plus 360 degrees, which would be 326. And those will be my answers. Do the same thing for letter B. Go and find your magnitude, and then find your direction, and see what you get, and we can compare answers. Go and pause it. Excellent. So I need to find two things. I need to be able to find my magnitude, and I need to be able to find my direction. So to be able to find your magnitude of vector u, it's going to be the square root of negative 3 square and 4 square. Remember, when you find the magnitude, basically you're looking for the length of the vector. So it'll be 9 plus 16, that'll be 25. So therefore your magnitude is not plus or minus, just 5. Your direction, I'm going to use my tangent theta is y over x, so in this case b over a, 4 over negative 3. I'm going to use my calculator. And I'm going to find my inverse tangent. I'll place in parentheses just to be safe, 4 over -3. And that gives me my angle is equal to -53.13. Now, some of you guys automatically, I need the positive version, and some of you guys just add 180 degrees. But you have to be careful because you want to make sure that you do make a quick sketch. -3 and +4. So I need more towards my left. -3 and +4 is up here. That is the vector that I'm looking for. The length is 5. Like we have a 3, 4, 5 triangle. But the magnitude, the calculator is giving me this angle over here. And yes, in this case, you do need to be able to add 180 degrees. But the only way to be able to determine whether you need to be able to add 180 or 360 is to be able to sketch your vector. So in this case, will be plus 180 degrees. And some of you are going to get this question wrong on the test just because you are being stubborn and not making a quick sketch. So we find your direction. We found the length of the vector, which is the magnitude. Now, make a x and y axis. We are going to develop the formulas that we have here. And so make a quick x and y axis on the first quadrant. Go and glue it, copy it, and then we can start. Once you're ready, go and pause it. Excellent. So we're looking for the horizontal and vertical component. So let's assume that we have our same vector here. We'll actually replace it. Doesn't matter. Here it's fine. Well, we have your vector AB, and we are looking for the horizontal and vertical components. So I'm going to make a right triangle by making a perpendicular line. So therefore, this is your x and y. This is, in this case, will be your A, and that's your B. And this is your magnitude. Where this is your angle. So therefore, if we're looking for A and using your magnitude, this will be your adjacent over hypotenuse, and we're dealing with the right triangle. So therefore, the cosine of the angle will be your adjacent over your hypotenuse. And I'm going to leave that A by itself, so therefore I'm going to multiply by the magnitude on both sides. That cancels out. So therefore A equals the magnitude of the vector multiplied by the cosine of A. This is the cosine of theta. And that's how we get your first formula. And now if we're doing the same thing but now with B, for your angle, this is your opposite over hypotenuse, so it'll be the sine of theta equals B over your hypotenuse, which is your magnitude, multiplied by the magnitude on both sides. That will cancel. So therefore B equals the magnitude of the sine of the angle. And this should be in bold. And that's what they get your second. So these are two equations that you have to memorize for your test. And therefore, since this is your A and that's your B, we can rewrite the components in this form. The component vector can be written down in this form since that's A and that's B. Example number 4. Go and take the time to copy it down, and then we'll start once you're ready. Excellent. So in this case, vector W has a magnitude of 25 and a direction of 41.7. Remember, your magnitude is going to be the force or the velocity. So it could be 25 pounds, it could be 25 miles per hour. In this case, we just have 25. Find the horizontal and vertical components. So I need to be able to find, they tell us that your magnitude is 25. And we know the notation that we use. Well, that's W. And your angle is theta. So therefore, to be able to find your A component, we know it's going to be the magnitude of your vector and the cosine of your angle. To find your B component will be your magnitude of your angle, of your vector, multiplied by the sine of theta. So we're just going to substitute 25 times the cosine of 41.7. And B will be 25 multiplied by the sine of 41.7 degrees. Don't forget to place your degree signs. And now we just type into the calculator 25 cosine of 41.7 degrees, which is 18 point. We just need 2 decimal places, 67, approximately 18.67. And B, I'll type in 25, the sine of 41.7, so it'll be 16.63. And that's an approximation, 16.63. So therefore, your vector AB will be approximately 18.67, and that is your vector W. And notice that if we do sketch it, if we just do a very quick sketch, it's going to be, it's positive and positive. 18, about the same on both. Your Y is a little shorter. Notice that your angle does match, should be 25 degrees. Even though it looks a little, 40, yeah, looks like a 45. It's 41.7, that's correct. And the length will be 25. So your angle is 41.7, which matches the information that's provided for us. So it does work. Example number 5. Write each vector in the following form. Go and pause it, write it down, and then we can start once you're ready. So sometimes they give you this vector, and they just want you to be able to simplify. And sometimes they'll allow you to use a calculator. In this case, if you give it to you, 60 is one of the angles that we do know. So at this point, you should have it memorized, and I know that all of you guys do. So we have 5. Do you guys remember, what is the cosine of 60 degrees? Cosine of 60 degrees will be longer or shorter side? Shorter side. So there'll be 1/2. 5, the sine of 60 degrees, that'll be your longer side. So it'll be square of 3/2. So therefore, your vector equals 5/2, comma, 5 square of 3/2. And for letter B, go through the same process, see what you get, and we can compare our answers. Excellent. So in this case, go and pause it. You got it? So vector V will be 2 cosine of 180 degrees. Cosine is your x value, so it will be negative 1. And 2 sine of 180 degrees will be 0. So your vector equals negative 2 comma 0. And notice that if you sketch it, if you just do a very quick sketch for each one, it should match. And it does in this case. So negative 2 and 0. This is your magnitude. The length of the vector, this is v, is 2. And this is your direction. Your direction is 180 degrees, so it should be able to match. Go ahead and paste your next cutout, or go ahead and take the time to copy it down, and then we'll start once you're ready. So in this case, for this cutout, it says vector operations. So if you have two vectors, u and v are going to be vectors, and k is just a number. It's going to be what we call a scalar. So it's just a real number. Then we can actually just add the vectors by adding the components, subtract the vectors by subtracting the components, and we can even multiply by a scalar, by a specific number. And to multiply, we just basically just multiply each of the components, and we can think of it as just distributive property. We can distribute the k to both. Now, it is essential that we actually not just add them manually, or just the components, we actually know what is happening for each one. So example number 6, AB, and then we'll continue with C and D in a few minutes. Take the time to copy it down, and then we'll talk about the geometric aspect of it. Go ahead and pause it. And we have example number 6. Let's go and make a 5 by 5 graph for each one. So 2, 4, 5, 2, 4, 5, 2, 4, 5. And on this problem, you do want to make sure that you sketch it, because doing the algebraic aspect of it is very easy. But you want to be able to understand, as we go into word problems for the next sections, what's happening when you multiply or when you add two vectors. Are you ready? So let's start with the first one. Vector 2v. V is negative 2, 1. Remember that this vector is already grounded. So therefore, we're going to, this is start 0, 0, negative 2 and up 1. So that is your vector. And you want to make sure that you do it algebraic, graphically first, and then check your algebraic component afterwards to make sure that you actually are doing it correctly. So 2v, we're going to multiply the vector times 2. So we're going to take this vector, and now we're going to extend it. So it's going to be multiplied by 2. The length will be multiplied by 2. So now we are going to take this vector and we are going to multiply by 2. So now that'll be the new vector. As you can tell, my new vector will start at 0, 0 and will end at negative 4 and positive 2. That is geometric. Algebraic, we're going to take 2 times your vector negative 2 1. We are going to multiply each of the components, so it gives you negative 4 and 2. And our vector matches. Easy as that. Now, when we add, it's a little more challenging, but some of you guys have seen it in physics. So let's draw each of the vectors, negative 2 and positive 1. That's vector V. Vector W is positive 3 and up 2. And we have options. So we do have options. So I take my vector, this is my U, my V, and this is my U. So I have a choice. I can move this vector over here. So I can, remember, vectors can be moved around. Remember that we talked about this at the beginning of the lesson? So I can move this vector W at the very end and move it to here. Or if I want, I can move that V and move it over here. Notice that either way, it's going to end here. So I'm going to move my W at the end of V, or I'm going to take my V and move it at the end of W. Which way do you guys prefer? It doesn't matter, correct? So therefore, I'm going to take my V. It's to the left 2 and up 1. Do you guys agree? 1, 2, and up 1. So I'm going to do the same thing. To the left 2 and up 1. And that's where he ends. I'm going to make a dash. Because it's not part of my vector. And I'm going to do the same thing here. Remember, if you have done this vector, you go 1, 2, 3, and up 2. From the end, 1, 2, 3, and up 2. Your resultant vector, which is the vector that we're looking for, is this vector here. So therefore, let's go and label it. This is U. This is V. This is W. And just do, and this is V plus W. I don't need the double bars. But now let's do it algebraic. W is 3 and 2 plus negative 2 and 1. So therefore your resultant vector will be 3 minus 2 will be 1. 2 plus 1 will be 3. And it should match to the right 1 and up 3. Perfect. So, but you do need to be able to do algebraically and geometrically on your homework, because I want to make sure that you guys understand that how to be able to get your component, your new vector. Let's try C and W, C and D. So once again, I'm going to go and build a 5x5 graph. I'm going to do that for each. It is essential that we do it geometrically first and then compare our answers algebraic. And one of the things that people get lost on this chapter is because they refuse to learn it geometrically. They just want to do algebraically and they kind of lose all the concepts behind it. So let's go and draw vector V, which is negative 2 and positive 1. Now let's go and from there we are going to draw W, which is 3 and 2. Let me label them. This is V and this is W. So what's happening first? V plus 2W. So what we need to do first, we need to be able to take 2W, and remember, to be able to do 2W, basically I'm going to multiply by 2. So this is 3 and 2, so it'll be 3 and 2 will be up here. Same thing with that we did on letter A. So therefore this is just 2W. And now we can go and add it. And you need to decide, do you want to move this vector over here, or you want to move this vector over here? I'm just going to move the smaller one. So to the left 2 and up 1. So from here to the left 2 and up 1. I'm going to make it as dash. And now if I move this vector over here, it'll be to the right 6 and up 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It basically comes to the same endpoint. So once I move one, then I know where the other one should be. Your resultant vector is here. So therefore this one is V plus 2W. And now let's do it algebraically. V is negative 2 comma 1 plus 2W, where W is 3, 2. So we're going to multiply first, plus 6, 4, and that's what we have here. And now we can add them, so that gives me 4 and 5. And that should be your resultant vector. 1, 2, 3, 4, 1, 2, 3, 4, 5, and that matches perfectly. So let's try the next one. Let's go and draw vectors V, which is 2 and negative 2 and 1, and 3 and 2. This is V, and this is W. So therefore, whenever we have a subtraction, what we're going to do, we're going to rewrite it as an addition. So we are going to do vector W plus negative V. Something that we've done back from when you guys learned to add numbers. So you guys agreed that both of them are the same. So what we're going to do, we're going to take the opposite vector of V. And what happens when you do the opposite vector, instead of forward, we're going to shoot it backwards. So therefore, this will be your vector V. So therefore, whenever you take a vector, a negative vector, instead of going forward, you're going to shoot it backwards. And now we can add to W. So this is negative V vector. And now we can add them. So you need to decide whether you want to move this vector over here, or you want to move this vector over here. I'm going to move the smaller one. So it'll be to the right 2 and down 1. To the right 2 and down 1. I'm going to move it over here. I'm going to place it as dash. And I'm going to connect them. As if I move the other vector over here, they should connect. My resultant vector is this one here. And that should be 1, 2, 3, 4, 5, and up 1. Now let's go and try algebraically. Let's see, W is 3, 2. I'm just going to use minus V, which is negative 2, 1. I'm going to think about distributing property. I'm just going to change to an addition. But if I distribute, I still have a plus now in between. And that's what we have here. So now it's 2 and negative 1. And that's what we have here, to the right 2 and down 1. So it does match. And I can add them. So that will give me 5, and 1. And it does match my new vector, which is perfect. Go ahead and copy it down or paste it from your cutouts. And example number 7. And we'll continue once you're ready. Excellent. So we have linear vectors, linear combination of vectors. The unit vectors 1, 0, and 0, 1 are the standard unit vectors and are denoted as the following. So if you write on the left hand side, we're going to make a quick x and y axis just on the first quadrant, since both unit vectors are positive. So first we have I is 1, 0, 1, 0. So therefore this vector here, it's a unit vector I. And this vector is that's not correct. Do you guys see it? So this is I, just 1, 0. I can do this. J is 0, 1. This is J. So our unit vectors, your X is I, your J is your Y. And those are your unit vectors. These vectors can be used to represent any vector V equals AB, and we are going to rewrite them in the following form. So it's going to be the sum of two vectors where you multiply the I by your A value and your vector J by your B value. So now instead of having this form of your vector, there's some parts in math that we need to go to rewrite it in a different form as your unit vectors. So let U be the vector with initial point 3, negative 2, and the terminal point 2, 3. Write U as a linear combination of the standard unit vectors I and J. Then find its magnitude and the direction. So in order to be able to rewrite it, first I'm going to rewrite it in this format. And do you guys remember how to take, and let's make a quick sketch on the right hand side so we can actually visualize what's happening here. So I'm just going to make an x and y axis. I just need mostly positive. 3, negative 2 is my initial point. My terminal point is at 2, 3. So remember that what we want when we write down in this format, we are going to take our vector and what's going to happen? We want to, correct, we want to ground it. Make sure I move it. There you go. So that's what we want to do. So therefore my vector should be negative 1, A value, and 5 will be your B value. So therefore we have the difference of your y's, of your x's. Remember to take your terminal minus your initial. So it'll be 2 minus 3. And 3 minus negative 2. So therefore, we used to write down your vectors as negative 1 and 5. Now we need to be able to rewrite it as a unit vector, A and J. So therefore, the only thing that we need to do is negative 1I plus 5 j. So let's talk about what's happening here. -1 and a 5. We grounded it. So basically it's saying that you're going to take your I unit vector, where that is at this one, and we're going to multiply by -1. So remember what happens when it's a negative? You just multiply by negative. And you're going to take your j, and you're going to multiply by 5. So 1, 2, 3, 4, 5. And we're going to add those two vectors. To add those two vectors, basically you're going to move it up here. And this will be the sum. That will be this vector here, which is this vector here. But one of the things that you have to remember is that you basically are just multiplying your unit vector. So u equals -1, and your I, just like we have above, is 1, 0, plus 5, and your j is 0, 1. And if we multiply it out, gives me a -1, 0, plus 5, 0. If I can multiply 5 times 0, 0, and 5, which will give us, add your x values or your a's, which is -1, and 0 plus 5 is 5, which is exactly what we had before. So it seems like a little redundant, but there are some parts in mathematics that we need to be able to rewrite in this form, especially as you go into three-dimensional figures. Some of your computer science majors will be seeing this. Photography might be able to see it as well. But you need to be able to realize that those two are the same and why. This is essential. You need to be able to remember that your I vector is your unit vector, which is 1, 0. Your j vector is your unit vector, which is 0, 1, and what they represent. You also need to be able to remember that you can actually convert back into your component vectors. And you also need to be able to understand it graphically. So it's very simple, but at the same time it can be complex if you don't fully understand it. And the last example for today. Now 11.3 in your textbook, they combine all of these components into one lesson. We're actually going to do it in 2 different lessons. So go and copy it down, and then we'll continue once you're ready. So we have 2 vectors, u and v. I need to be able to find 2u minus 3v. So in this case, to find 2u minus 3v, we're just going to substitute u vector is -3i plus aj. Remember, I is the unit vector, which is 1, 0. J is a unit vector, which is 0, 1. Plus, minus 3v is 2i minus j. And we're just going to multiply out. -6i plus 16j minus 3 minus 6i minus plus 3j. We are going to combine all like terms. It's actually, ideally I should have a plus in here, and I should have this in parentheses because we still have 2 vectors, and that gives me a -12i plus 19j. And if we want, we can actually represent this geometrically just like we've done before. Do you guys want to do so? So build the x and y axis, but in this case the numbers do pretty large. And that's it. That will conclude the first part for 11.3, and then we'll continue next time. Please email me if you have any questions. Have a great day.